This is my review of Module 1 for our History of Engineering class. We're going to start out by talking about early American engineering. Back in early America, there weren't really any formal ways for somebody to become an engineer. There weren't any schools. Most of the people that you would find were either inventors or entrepreneurs. You really didn't see anybody having any sort of formal path to becoming an engineer. It was mostly just people who were good at creating systems and figuring out how things worked. Because of that, a lot of the American engineers drew influence from British and French engineers. I think some of the parts that we drew from the French are things like creating sort of a state run like the Army and Corps of Engineers, for example. That comes a lot later, but things like the Erie Canal were built, by the state, but you saw much more of the British style of the people who were actually working, were learning on the job, were apprentices, and again, they weren't those people who necessarily came out of a school or something like that. It was much more hands-on. And I think because of that, you see a hybrid system get made in America that combines sort of the British and French engineering traditions. Then we kind of moved on to what engineering was like, sort of talking about that experience versus knowledge type of thing and what is more important. Is it more important to have the basic scientific understanding behind what you're doing, or just knowing how to get through the nitty-gritty and make things work? Engineering was extremely hard work. It was not something that most people would probably want to do. I think you probably had to be a little crazy actually to want to do something like that. It's not like engineering today. We see that a lot in some of the challenges with the Erie Canal. A lot of the engineers had to go through things that they had never experienced at any other type of job. Jarvis's readings from the text really show that well. You see a lot of the engineers, mucking it out through things that we would never ever want to do today, like camping out in the middle of the snow to finish canals. Then we sort of moved on to sort of the politics of the technology and engineering in general. Obviously, a project like the Erie Canal is going to benefit certain people. And whenever engineering is involved, it's always going to be a battle between who does it benefit and who does it not. An example with the Erie Canal is that a lot of the trade will now be brought through New York because of the canal, whereas it will go through Montreal and Philadelphia and places like that a lot less, which does not benefit those people, but benefits the people of New York. Something I also found interesting in the course was sort of attitudes towards engineers. Engineers were not looked on as some sort of high-class, rich job like it is now. A lot of people who go into engineering these days want to make a lot of money and are very smart. And a lot of these people sort of came up from nothing and just sort of pushed through and learned how to do these things and make engineering work, which I think is very cool.
Hi class, I'm here to discuss Module 2 for the History of Engineering Midterm. The time period that I'm discussing is 1850 to about 1900. And during this time period, we saw a large growth in the engineering profession. We saw a large growth in engineering education. And we also saw the creation of professional societies and the pursuit of a professional status by engineers at the time. So after 1850, we had a population and manufacturing surge in the country. Our population grew to over 75 million people, and our manufacturing grew similarly. During this time, you also saw the rise of corporations. They became influential in government and began setting a lot of their own policies. The takeaway is that engineering at this time was driven by profit. That created a real conflict, right? Because as engineers, they wanted to pursue the science, but as employees, they were kind of constrained by business. While that was going on, there was also a push for more engineering education. So at the time, engineering was still really on-the-job based, right? And so Ashbel Wells, who believed in on-the-job training, thought that too much education would diminish the engineer and they become too much in their head or too theoretical. Whereas William Burr would have believed in the theoretical training, right? The ability to conceive an idea on paper based on the theory and then apply it. So at this time in education, there were only a couple of engineering schools. West Point had one of the first engineering schools, along with Norwich University. But then in 1862, right during the Civil War, Justin Morrill came up with his land grant, which basically allowed the federal government to give states land for free, which they were allowed to sell if they took that money and they used it to build colleges. A lot of states took advantage of this, and they used that money to build colleges that were based in agricultural and mechanical education, which would eventually become an engineering education. And so now that you have all these engineers and they've received this education, you began to see the rise of engineering societies, professional societies, right? The keys with professional society is to promote the profession, come up with a set of standards that everybody adheres to have an ethical code that everybody adheres to. And then by doing this, their attempt was not only to create a standard, but also to create prestige. One of the first societies for engineers was the American Society of Civil Engineers, which was founded in 1852, and they believed highly in theoretical knowledge. At the time also, in about 1871, the AIME was formed, and this professional engineering society was really to support people who were in the mining or the metallurgy field. There were others. After that, the ASME for mechanical engineers was formed in 1880, and the AIEE for electrical engineers in about 1884. So that, in a nutshell, is Module 2. Thanks very much.